Hare Krishna. Hope you're doing well. Let's get started with this question. Inherently on the regression based problem only, where we have the two original random variables as x and y, and we are seeing a transformation of both of them. They are shifted and then scaled, both of them. And we have to see what this quantity is. Okay, let's get started. Implicitly speaking, this quantity, when we'll notice for the original variables, it's essentially the correlation coefficient of them multiplied by the ratio of standard deviations. So this is the correlation coefficient and yeah, standard deviations. So similarly, for the new set of random variables also, this would be the correlation coefficient between them multiplied by the ratio of their standard deviations. Now all that needs to be done is we compute this quantity and this quantity. Okay, so if we start with the variance of u, which is variance of x minus a by h, the minus a by h part, which is the constant, gets removed from the variance. So we are left with this. And the scalar multiplied with the random variable, which is 1 by h, that comes out, and we have 1 by h square variance x. So when we take the standard deviation, which is the square root, we get sigma u equals to sigma x by 1 times 1 by h. Similarly, for variance v, which is associated with y, the constant part will vanish and the scalar part will come out and square up. So we'll get this. And when we take the square root to get the standard deviation, we'll get this. For the covariance, we have x minus a by h, y minus b by k. So again, over here, we would have the constant parts minus a by h and minus b by k removed, and we would have covariance of x by h comma y by k. The scalars multiplied will come out and we will have this. So we have the correlation coefficient of uv expressed like this, and when we break it in terms of the original variables, we get this as per our computation over here and here. So the correlation coefficient is the same as the correlation coefficient of the original variables. This is a very important property, that the correlation coefficient is invariant under change of scale and change of mean. So this is an important thing. And so we take this, put this values, substitute the expressions in the original with respect to the original random variables, and we get this thing. Now this thing is something we already know. This is the starting point bxy. So this becomes this, and we have the right answer here. That was it. Take care. Hare Krishna.